Good evening, good evening, good evening, everyone. I pray that you are having a blessed and wonderful day. Happy Wednesday, happy hump day. So thankful and grateful that we can get over the hump of today. Now, we are still within our tutoring session this week for Algebra 1. I'm gonna continue on from where I stopped, which yesterday our last review was of the one step evaluation for solving equations. So once you guys come in, double tap, hit a couple of like buttons to let me know that you can hear me, hit some hearts, thumbs up, all that good stuff. Once I get that from you, we can get started. Why, thank you. Thank you, thank you, thank you. I'm glad that you can hear me. Let's get started. So, today we will be learning how to do two-step equations. But first, I am going to do a review on the one-step equations, shall we? So, first problem is x plus 5 equals 8. Let's rewrite this again, this time maybe a little neater. How about it? Okay, so now x plus 5 equals 8. In order to solve this equation, which means we have to get x by itself, the one step would be, of course, since we are adding 5 to x, we must subtract 5 on both sides of the equal sign in order to get x by itself. And of course, once you do that, you bring down your x. Then for the plus 5 minus 5, of course, you could either cross that out or do minus 0. Equals 8 minus 5. 8 minus 5, that is 3. So then, of course, x minus 0, well, correction, x plus 0, because the 5 was being added, so therefore we would still do a plus 0. So x plus 0, of course, is identity. Identity says x plus 0 is x, and of course, x will equal 3. So now, when you are solving one-step equations, remember that if you are adding a number to the variable, you must subtract that number from both sides to get the variable by itself. Next, we have y minus 4 equals 3. Now, y minus 4 equals 3. Same process. 4 is being subtracted or taken away from y. How do I get y by itself? By adding 4 on both sides. Once I add 4 on both sides, that will cancel. I'll bring down my y, minus 0. And of course, 3 plus 4, that gives me 7. Once I cancel out or bring down my 0, whichever you prefer, y minus 0 still gives me y, and that equals 7. Next, we will go through my handy dandy problems. I'm going to do 5g is equal to 20. Now, remember, 5g is also known as 5 parentheses g or 5 times g. Either way you write it, know that 5g means that you are multiplying the 5 to g. So, how do we remove or how do we get g by itself? Well, in order to get g by itself, you will divide by 5 on both sides of the equal sign. And of course, 5 divided by 5, that will cancel each other, or if you prefer, you can write 1g because 5 divided by 5 is 1, and then equal to 20 divided by 5 or 20 over 5, or what times 5 gives me 20, that would be 4. Okay, so once I bring down my 4, then of course 1g is the same as saying 1 times g. So 1 times g is g, and that g equals 4. Now, of course, with all of these equations, in order to check your answer, you can always go back to the original problem and say, hey, 5g equals 20. And then, since we know that g equals 4, 5 times 4 equals 20. So that means 20 equals 20. And that is how you can check your one-step answer. Any questions so far? Hey, Carlene. Thank you. All right, next up, we of course have a division problem, which says y over 3 equals 5. Now, how do I get the y by itself when it's being divided by 3? Well, in order to get the y by itself and it's being divided by 3, you multiply by 3 on both sides of the equal sign. Once you multiply by 3 on both sides of the equal sign, this will allow you to cross out your threes. Now, how are you able to cross out your threes? Well, if you remember when we had multiplication of fractions, a whole number is always over 1. So when you're multiplying a fraction and you take the whole number and put it over 1, you then can multiply across, which will give you 3y over 3, or just cancel out the 3's, and that will still give you y. Now, once you cross those out, 5 times 3 gives me 15. Best way to check my answer, y over 3 equals 5. We know that y equals 15, so 15 over 3 equals 5. And of course, 15 over 3 is the same as saying 15 divided by 3, or what times 3 gives me 15? That, of course, is 5, and 5 equals 5, and that allows you to check your answer. All right, beautiful people, we are going to move on to our two-step problems of chapter 3. Now, as you well know, two-step is exactly what it means. It takes 2 exact steps to solve the equation. So say, for instance, I have x divided by 2, and it's being added 3. Actually, make that 5. And that equals 11. So now, all the individual steps we learned, now we can combine those together. And here's how. So, whenever you are trying to solve for x, you first have to get the plus or minus sign away from the equation. So how do you do that? Well, we know that the 5 is being added to the x over 2. So to get rid of the 5, I will subtract 5 on both sides, which of course, once I cross that out, that'll give me x over 2. And x over 2 is brought down. The plus and minus 5, they cancel out because that equals 0. Bring down your equal sign, and then 11 minus 5, well, that is 6, right? So after I find that answer, I then in turn multiply by 2, because I'm still trying to make sure that I get my x by itself, because of course you have to remember, all we're doing in this part of algebra is solving for the unknown. Algebra is best known as the math of the unknown and solving for it. So to get x by itself, I multiply by 2 on both sides. It is very important that when you are multiplying, adding, subtracting, or dividing, when you're doing the opposites of each component of your solving equation, make sure you're doing it on both sides of the equal sign, always. So now, the 2 2's cancel, which leaves me with x. And of course, x will equal 6 times 2, and that'll give me 12. Now, once I solve for x, I then can turn around and put it back into the equation to check my answer. So we know that x equals 12, and the original equation was x over 2 plus 5 equals 11. So now x equals 2, so that means I could change x into 12. X equals 12, so therefore I can change x into 12 in the equation. So 12 over 2 plus 5 equals 11. 12 divided by 2, because of order of operation, is 6 plus 5 equals 11. And of course, 11 will equal 11. And that is how we can check our answers. Any questions? All right. Moving on to more example problems for this. And just to get you more understanding of how this works. So let's try 3x plus 7 equals 19. So now we know that the 3 is 3 times the x and is the sum of 3 times the x, and 7 is 19. So how do I solve or find x? Well, first things first, I must get rid of my plus sign. How do I get rid of my plus sign? By subtracting the 7 on both sides. Bring down my 3x plus or minus 7, those cancel, which leaves me left with my equal sign. And then 19 minus 7, that leaves me with 12, because 9 from 7 is 2, and you bring down your 1. Now, how do I get the 3 away from the x, seeing as how 3 is times x? Well, of course, if you remember, we divide by 3 on both sides. Once I divide by 3 on both sides, the 3's cancel or divide out, and I'm left with x, and then x equals 4. And of course, you can check your answer by doing this. We know that x equals 4. And our equation was 3x plus 7 equals 19. So x equals 4. Therefore, I can change x into 4, add 7, and it equals 19. So now 3 times 4, that's 12, plus 7 equals 19. 12 plus 7, that gives me my 19, which equals still 19. And this is how you can check your answer. Here's another example problem of something you might run into when you are dealing with fractions in the equation. Five over 6c minus 8 equals 7. Now, earlier I taught you guys about making sure that when you're trying to get rid of the fraction, that you multiply by a whole number. Now, what happens if your numerator is not 1 in a fraction? Here's how we can solve it. First things first, we have to get rid of this minus sign. So, to get rid of the minus sign, I'm going to add 8 on both sides. Adding 8 to a minus 8 will allow that to cancel out or make it 0 out. And what you're left with on the left side of the equation is 5 over 6c. And that will equal thanks, guys. 5 over 6c will equal 15. So now, once you have gotten to this point, normally, if it was 1 as your numerator, I would tell you to multiply by 6 on both sides. But seeing as how we have a full fraction and the numerator is not 1, we must multiply by what they call the reciprocal or the flipped fraction. All that means is that if you have 5 over 6, I'm multiplying by 6 over 5. And if I'm multiplying by 6 over 5, I'm multiplying by 6 over 5 on both sides. Because what you do on one side, you must still do on the other. So now, if I multiply by the flipped fraction, 6 times 5 is 30, 5 times 6 is 30. 30 over 30 will give me 1. Or simply put, if I have a 6 in my numerator multiplied by a 6 in my denominator to a second fraction, those can cancel. If I have 5 in my numerator of my second fraction and a 5 in my denominator in my first fraction, those two can cancel. Once you cancel out all the numbers, what you're left with is the letter C. So then, once I cancel that out, you can then say 15 times 6 and then divide it by 5. Or, my personal favorite, canceling within multiplication. So, what does that look like? Well, 15 and 5 both have the number 5 in common. So, if I divide 15 by 5, that will give me 3. If I divide 5 by 5, that'll give me 1. So then now I am multiplying the 3 to the 6 and dividing by 1, which leaves me with 18. I know you guys like, Miss Chris, what in the world is all of that? We did go over this in our multiplication operation Saturday. So if you review that, you will be able to see this. But if you didn't see the multiplication portion of our live, guess what? I'm going to keep going with these type of problems until you get it. All right, let's try 2 over 7n plus 4, and that equals 10. All right. Of course, we must get rid of our plus or minus sign first. So to get rid of my plus sign, I must subtract 4 on both sides. Once I subtract 4 on both sides of the equal sign, I am going to cancel out my plus 4 minus 4, which leaves me with a 2 over 7n equals 10 minus 4. 10 minus 4, of course, is 6. Once I get to 6, I will multiply by my flipped fraction or my reciprocated fraction, which is 7 over 2. I do that on both sides. And of course, crossing out the 7 on the top, crossing out the 7 on the bottom, crossing out the 2 on the top, crossing out the 2 on the bottom. And that, of course, will leave me with n. Now, of course, you still can do this 2 ways. The long way would be 6 times 7. That'll give me 42. And then, of course, 2 times 1, that gives me 2. And 42 divided by 2, that gives me 21, right? Or I can cross out my 6 and my 2 because 6 and 2 both have a number in common. 2 will go into 6 3 times. 2 will go into 2 1 time. 3 times 7, that gives me 21. 1 times 1 gives me 1. And of course, 21 over 1 is still 21. Any questions before we move on to the next section? Of course, if you do have questions, please comment them below. You can type them up into the comment section. Also, it probably would have helped if my 42 doesn't look like a 4Z. Let me rewrite that. Much better. All right. Moving on to the next subject, which of course means we are going to solve multi-step equations. Now the question would be, okay, why would the algebra book go from 1 step, 2 step, and then multi-step? Well, of course, with any solving of equations, we want to start you at the baby level, which is the beginner's level. Everyone has to start at the beginning. The beginning, of course, is the 1 step. Intermediate or teenage level, that is what I call the 2 step. And of course, the dance is also called a 2 step, but that's neither here nor there. But the final level, of course, would be the multi-step. The multi-step means you can do 3 or more steps within your equation to solve it. So this is where you start hearing things like combine like terms or getting all like terms to the same side. And here's an example of what I mean. Now you have 8x minus 3x minus 10, and that all equals 20. Now, normally we'll have a term with an x, a number adding or subtracting, and then that would equal a number. Well, you're getting into the thick of multi-step when you start combining like terms. So combining like terms simply means I'm adding and subtracting terms that are alike. So the terms that we have that are alike are 8x and 3x. The reason why you can add or subtract them from each other is because they both have x to the first power. Now, if this was 3x squared, you cannot combine them because they must have the same degree or same lettering in order for you to add and subtract them from each other. So now, 8x minus 3x, that will give me 5x. That's step number one. Then I bring down my minus 10 and I equal it to 20. Looks familiar? Now we're back at what? The two step. So now to get 5x by itself or to remove my minus sign, I must add 10 on both sides. Bring down my 5x. Cancel out my minus 10 and plus 10, and that will equal 20 plus 10. That is 30. Then once I add those two together, I must divide by 5 on both sides. And of course, x is going to equal 6. All right, I am going to do a few example problems. Some of these you will see a lot when you're working with your student, or if you are the student, this is what you're going to see when you're doing algebra on all levels. So multi-step simply mean I am combining like terms or I'm shifting stuff around in order to solve for x. So here's an example. Here's a few examples. First example is p plus 2p minus 3 equals 6. On the left side, we have like terms, so I'm going to add p to 2p, which of course, if you have a single p by itself, is understood as 1p. So 1p plus 2p equals 3p. And then 3p minus 3 equals 6. Then, of course, you follow through with your two-step of plus 3 on both sides, because I must get my 3p by itself. Bring down my 3p, cancel out my minus 3 plus 3, which will equal 6 plus 3, and that gives me 9. Right? After that, we divide by 3 on both sides. Once you divide by 3 on both sides, that will give me p equals 3. All right. Next, I'm going to do an intermediate multi-step problem. And that would be 3 plus 4 times z plus 5, and that equals 31. Now, with this type of problem, you must first, in your multi-step equation, distribute it within the parenthesis. Meaning I'm going to multiply the 4 to the z, and I'm multiplying the 4 to the 5. So I'm going to bring down my 3, and then plus 4 times z will give me plus 4z, and plus 4 times plus 5, that gives me plus 20, because positive and positive makes positive, and 4 times 5, that gives me 20, and then that equals better, 31. Sorry, guys, had to get my box together. Okay, so now 3 plus 4z plus 20, that equals 31. So now I'm going to combine like terms on the left side, because there are terms that are alike on both sides, which is the 3 and the 20. So I would bring down my 4z, because that has nothing to combine with. Then I have my 3 plus 20, which gives me plus 23, and that equals 31. Now we're back to what we know best, which is the two-step. I'm going to minus 23 on both sides. Screen up a bit. Bring down my 4z. 23's cancel, and 31 minus 23. Anyone? Thank you. 31 minus 23 is 8. Good job. So now I'm going to divide by 4 on both sides. And 4's cancel. That leaves me with z. And 8 divided by 4, that gives me 2. I'm going to do one more intermediate, and I'm going to do another advanced, and then we are going to move on to the next section. Next, we have three C minus 3 times 6 minus 2c, and all of that equals 27. Now, like before, we are going to distribute the 3 to the 6 and the 3 to the 2c. Now, keep in mind, this is a minus 3, so signs are going to change based on this minus 3. So first thing I will need to do is bring down my 3c. Next, I am going to multiply my -3 to my +6, which is a -18. And then I'm going to multiply my -3 to my -2c, and that's going to give me a +6c. And all of that equals 7. So now, combining like terms, I have 3c, 6c, 6c plus 3c, that is 9c. Because that's a positive 3c, I'm adding it to the 6c. That makes that a positive 9c. Minus 18, because the letter comes before the number, equals 27. Now I'm going to add 18 on both sides. Of course, 18s cancel. Bring down my 9c. 9c equals, have 27 plus 18, 7 plus 8, that gives me 5. Carry my 1. Well, 7 plus 8 gives me 15. I bring down my 5, carry my 1. Then 1 plus 2 is 3, plus 1 is 4. So your answer, 27 plus 18, 45. Once you add those together, then you will divide by 9 on both sides. And of course, C will equal 5. Now, like I said before, if you are unsure of your answer, you can take it and plug it back into the original equation. Once you do that, your answer should equal the number on the other side of the equal sign. If it does not, that means one of the numbers got mixed up within your adding and subtracting. Start over, try again, it happens. All right, this is going to be our challenge question, which is my advanced question. Gonna do 2 of these, one with a numerator of 1 and one with a numerator more than 1. So we are going to do 1/3 times D plus 3, and that is going to equal 5. Now, I know you're looking like, am I going to have to distribute this fraction to the letter and the 3? You can do that, but then you'll have D over 3 plus 1 and all that extra stuff that really can be easily eliminated. And here's how. Since the 1/3 is times the D plus 3, all you have to do is multiply by 3 on both sides of the equal sign. This will eliminate your fraction. Cross out the 3's, bring down my D plus 3. And of course, 5 times 3, that gives me 15. Of course, once I bring down my D plus 3, I subtract it. On both sides, and D equals 12. Now, I can go back and show you the long way of this equation, which would have looked like 1 over 3 d plus 3, and that equals 5. Distributing wise, that would have been 1/3 d, and 1/3 times 3, that would have been plus 1. Because 1/3 of 3 is 1, and that equals 5. And of course, subtract 1 on both sides, and I have 1/3 d equals 1/3 d. That'll give me equals 5 minus 1, which is 4, multiplied by 3 on both sides, and d is still 12. Now, the first version I gave you was I multiplied by 3 on both sides. That gave me 15, so all I had to do was subtract my 3 on both sides, and that still gave me my 12. Either one of these you can do. It is fine to do either one. I prefer to go ahead and multiply the fraction, the flip fraction on both sides. That way you can go ahead and get rid of your fraction without having to distribute it. But if you're the kind that like longhand multiplication, have at it. Now, here is one when your numerator is not 1. Four over 3 times 7 minus n, and that equals 12. Now, for me, of course, I'm going to multiply by the flip fraction, which is 3 over 4 on both sides. These cancel, and what I'm left with is 7 minus n, and that equals 12 times 3 is 36. 36 divided by 4 is 9, or cross out the 12, cross out the 4, because 4 will go on to 12 3 times, 4 will go on to 4 1 time. 3 times 3 gives me 9, and 9 over 1 is still 9. So now I'm going to subtract 7 on both sides, because that's a positive 7, which leaves me with a negative n, because the 7's cancel, equal 9 minus 7, which is 2. Now remember, I told you guys, in the variables cannot be negative. So whenever you have a negative in front of it, whether it's a negative understood 1, which is what we have now, or a -2 or -5, whichever, you must divide by that number on both sides. So divide by -1, divide by -1, and end equals a -2. Why? Because positive and a negative is negative. 2 divided by 1 is 2. Any questions before we move on to the next section? right, moving on. Next section, we are going to look at ratios and proportions. A ratio uses division to compare quantities. You can write the ratio of two quantities, A and B, where B is not equal to 0 in three ways. Now, if you remember in elementary, ratios can either be written as based on fractional and divisional proportions. You have A to B, A with a colon B, or you will have A over B. Now keep in mind, when you have A over B, B cannot be 0. A to B, A colon B, A over B. B cannot be 0. 0 in the denominator means it is undefined. You cannot find it. It is imaginary. And of course, we'll get into imaginaries at a later time. So now, example would be a volleyball team plays 14 home games and 10 away games. Find the ratio of home games to away games. Then find the ratio of home games to all games. What would that look like? So now we know that there are 14 home games. There are 10 away games, which means there are 24 games in total. So now the ratio from home to away simply means you are going to take 14 and you're going to put it over 10. Anytime you're dealing with a ratio, it's all the first word or first group is what you put as your numerator, and the second group as your denominator. So home games was first, you will put 14 on top. Away games was 10, so you put that on the bottom. And of course, you can simplify these by dividing by the greatest common factor between 14 and 10, which is 2. And that leaves me with 7 over 5, which another way of ratio would be 7.5 or 7 to 5. Whichever way you want to write it, that is how you would do the ratio. Also, the second question was find the ratio of home games to all games. Well, we know all the games are 24, so that'll be your denominator, and home games 14, which would be your numerator. Then, of course, you still will simplify them by dividing by the greatest common factor between the two, which is still 2. And 14 over 24 becomes 7 over 12. Any questions on ratios? Now, yesterday I touched on this a bit when I had the fractions equal each other. I had a number equal a fraction equal a number. This is also known as proportions. Solving for proportions simply mean I'm going to cross multiply my answer. And then once I cross multiply that answer, then I am going to solve for my x. So solve the proportion if 11 over 6 is equal to x over 30. Now, to solve this proportion, I will multiply 6 to x, and I will multiply 11 to 30. So 6 times x gives me 6x. And 11 times 30 will give me 330. Now, once I have these by themselves, then I will divide by 6 on both sides, just like we always do when it comes to single step equation solving. And 330 divided by 6 is 55. So that means x equals 55. So my proportion for this would be 11 over 6 should equal 50. Probably would help if I had more room. 11 over 6 equals 55 over 30. And of course, if you simplify 55 over 30, because 55 and 30 have 5 in common, 5 divided by 5 gives you 11. 5 divided by 6 gives you 5 divided by 30 gives you 6. Now, another way you could have done it was, instead of cross multiplying, have 11 over 6, and we still have x over 30. Okay, we know proportions mean my numerator should be proportionate to my first numerator should be proportioned to my second numerator, and my first denominator should be proportionate to my second denominator. So if the denominator went from 6 to 30, that means I multiplied by 5. So if I multiply my denominator by 5, I can also multiply my numerator by 5, and that will give me my 55. You also can multiply both sides by 30. And that will give you 330 over 6. The 30s will cancel, equals x. And of course, x equals 55. Just a couple of ways to show how to do your proportions. Now, say for instance, you have a word problem like we did with the ratios. How do you set this up? Well, I do have an example problem. The example problem says a recipe for tomato salsa calls for 30 tomatoes to make 12 pints of salsa. How many tomatoes are needed to make 4 pints of salsa? Well, we know that our ratio is tomato to salsa. So that should be T to S, or the pints of salsa. So We know that 30 tomatoes make 12 pints of salsa. So the next question is, how many tomatoes, which you could use for X, T, whichever letter you decide, makes up 4 pints of salsa. So now you can do any of the 3 methods. Here's my method. I'm going to cross multiply. So 12 times X, that gives me 12X. 30 times 4, that gives me 120. I divide both sides by 12. And X equals 10. Now, how can I check my answer? Well, we know that 12 divided by 3 gives me 4. So if I divide 12 by 3, I must therefore divide 30 by 3. And that, of course, gives me 10. So my answer is 10. Any questions before we move on to our next section? All right, moving along. Looks like we're about to go right into solving percent problems. What does that entail? Well, if you remember, we worked on percents and proportions, of course, in our elementary to middle school section. But if you missed it, here's a recap. Percent is basically dealing with still proportions. So this question asks, what percent of 25 is 17? So how do I solve this question? Well, if A is over B, then P as the percent must be over 100. So how do I get my percentage? Well, we know that we are looking for what percent is 17 out of 25. So whenever you have a question that says what percent of 25 is 17, this question is simply saying 17 out of 25 is what percent? So cross multiplication, I have 25. P That equals 1,700. And once I divide by 25 on both sides, P is going to equal 1,700 divided by 25. That gives me 68%. Now, caveat, flip, all this good stuff. What if you're looking for the number instead of the percent? What does that look like? So, what number is 15% of 88? So, how do I find this answer? You can do this two ways. You can either do 0.15 and you multiply it times 88, or we can go back to our proportions, which is, we know that 88 is the total. We're looking for the number, which would be A, that is 15% of the equation. So now, 0.15 times 88, that gives me 13.2. Or you have 100. When you cross multiply 100A equals 88 times 15, which is 1,320. So now, divide both sides by 100. And of course, A is going to equal still 13.2. So whenever you're trying to solve percent problems, if it says what's the percent, you are going to cross multiply and divide to find the percent, or you're going to cross multiply and divide to find the number that you're looking for. Or if you just want to simply go through all of it, what you would do for what number is 45% of 92 or 7% of 23, to find that answer, simply put, you take your percent, you move it 2 decimal places and put a decimal sign behind it, such as if I did what number is 45% of 92, that would be 0.45. Multiply that to 92. And what number is 45% of 92? 41.4. Again, of course, you still can cross multiply it. Like so. But for me, I simply just change the 0.45, the 45 over 100 to 0.445 because 45 over 100, you move two decimal places. Once you do that, you multiply by 92, you still get the answer of 41.4. Any questions before we move on? All right. We are now in chapter 4. And wouldn't you know it, chapter 4 is about something we already learned, but let's get back to how we learned it. Yes, we are going to have graphing paper. Why? Because we are learning how to plot points. Now, if you remember from the positives and negative on a system, that was for my 4th and 5th graders. If you remember, this is called the Cartesian, based on Rene Descartes, who is a great mathematician. He came up with the Cartesian, or the coordinate plane, that lets you know how to graph two-dimensionally, which means I'm graphing from left to right and I'm graphing up and down. So, as a recap for this, main thing you have to remember, there are 4 quadrants. Q1, which is all positives. Q2, which is all the x's are negative, but my y's are positive. Q3, which simply means all of them are negative. And then Q4 is when my x's are positive, but my y's are negative. Now remember, you always write your coordinates or follow your coordinates by first finding the x, then finding the y. So now, also you remember, if goes counterclockwise, which of course gives you the letter C for Descartes, or the Cartesian plane. So Q1, all positives. Q2, X is negative, Y is positive. Q3, all negatives. Q4, X is positive, Y is negative. Now, how do I plot my point on my graph? Well, let's see. Say, for instance, I have a point of 5, comma 5. Well, positive 5, comma 5 is going to be in the quadrant of 1, and I'm going to go to 5 first, and then 5x first, and then 5y second, and plot my point. Try that again, but make it a little more clean. So, start at 5. Start at 0, go to my 5 on the x-axis, then go to my 5 on the y-axis, and that gives me my coordinate plane of 5, comma 5. Always remember, you do your x, then your y. X, then y. So if I wanted a point in quadrant 2, I could go from 0 to negative 10, then 5, plot my point, and that would be negative 10, comma 5. Same thing if I am in quadrant 3. I'm going to go from 0 to negative 15, down to negative 10, plot my point. Make sure you circle your point and plot it. And that will give me negative 15, comma negative 10. And then, of course, I can easily go to 10 and then negative 10 for quadrant 4, and that will give me 10, comma negative 10. Positive, positive, negative, positive, negative, negative, positive, negative. Any questions for plotting my points? Now with this one, I am going to need a one-on-one type of graph. Ooh, yes, perfect. And it shows you the quadrants, yay. So now, x, y, negative x, and negative y. So this is good for when you are learning how to graph a function. Now, you can graph a function two different ways. First way would be, of course, with a table of problems, which I am going to switch to full mode of our whiteboard so you can see it fully. So now, table x, y, when I have the equation y equals 2x minus 1, you can do a table version, which allows you to do -2, -1, 0, 1, and 2. Usually you always want to have at least 5 points to plot in order to get a more accurate line, because of course this is a linear equation. Linear line, get it? So now, if I plug -2 into this equation, because for every x, there's one y, which allows you to have what? A function. -2 times 2 gives me a -4. -4 minus 1 gives me a -5. -1 times 2 will give me a -2. -2 minus 1, that gives me a -3. Then 0 times 2 is 0. 0 minus 1, -1. 1 times 2 gives me 2. 2 minus 1 gives me 1. And of course, 2 times 2 is 4. 4 minus 1, that gives me a +3. Now, once I do that, I can now start plotting my points. Starting with -2 and -5. That would be here. Then -1 and -3, that would be here. You know what? I'm going to make this a lot bigger so you can see it. It's going to be a little blurry, but I promise you it's going to be worth it. And of course, my computer does not want to be my friend right now. So what I'm going to do is move this here. And make this bigger. Now, much better. So now, okay. Let's try it this way. And then move you over here. It just does not want to be my friend right now, but that is okay. So we are going to start at -2 and 5. That goes here. So -2 and 5, that goes here. -2 Or better yet, let me try it like this. Yeah, let's try it with the mouse. Then we have -1 and -3. 0 and -1. 1 and 1. And then 2 and 3. And of course, once you have plotted your points, you can then draw your line as such, but make sure you draw it a lot more straight and more pretty than mine. Better. So you want to make sure you're connecting all your dots together while you are plotting your points on the graph. Now your graphs are going to look like linear or parabolic, which of course is quadratic equations. And you're going to start seeing stuff like and that is, my friend, is what I consider a odd function, which of course that's x to the third, x to the fifth, x to the seventh, all that good stuff. So when you are graphing, make sure that you are plotting your points and making sure that you are plotting them x, comma, y. Any questions on plotting your points? Now, here is a key way to plot your points when here's a way to plot your points when you have intercepts. Now, intercepts is going to have y, the concept of y equals mx plus b. B, of course, is your y-intercept. M is your slope. X and y, x is your input, y is your output. So now, how do I plot the equation of y equals x plus 3? Without a table, might I add. To plot that, you first need to find your y-intercept, which of course would be either a positive or negative number. Is it positive? If it's positive, meaning plus, it's going to be positive as your y. And of course, your x will be 0 because the intercept is on the y-axis. So now my y-intercept is 0,3 and my slope is 1 over 1. Anytime you have just a letter, that means your slope is always 1 over 1. That means you rise 1, you run 1, to the left or to the right. So to plot this, 0, comma 1 will fall here. And either I can go up 1, right 1, which will put me at 1, comma 4, or I can go down 1, left 1, which will put me at -1 and 2. And of course, once I do that, I will plot my line. And of course, plot it straight, so it's going straight through. And once you plot your point, you'll be able to see that based on your y-intercept. So y-intercept plotting is simply taking your point from your slope intercept, which you would find if it was 3. If it's plus 3, it'll be positive 3. If it's minus 3, it would be negative 3. And you would either go, when your slope is positive, you're going to go up 1, right 1, or down 1, left 1. Now, say for instance, you have a negative slope. Or if you have a negative y-intercept. Or if both are negative, what does that look like? All right, so negative slope, I will still start here at 0, comma 3, because my intercept is still a positive 3. So once I plot that point, then I can go up 1, left 1, and that puts me here. Or I can go down 1, right 1, and that puts me here. And of course, I draw through my line like so. And that gives me my negative slope. Same thing if I have a positive slope, but a negative intercept, 0, comma negative 3. Zero, negative 3, that's here. Positive 1 over 1 slope. Go up 1, right 1. Or from the original point, down 1, left 1. And plot my graph. And I know it's squiggly. I do apologize, but it's supposed to be straight. I promise. Of course, if it is a negative slope and you still have a negative intercept, that means that's going to be 0, comma negative 3. Start at my 0, negative 3. Plot that point, and I can go up 1, left 1, or down 1, right 1. And of course, you plot those points. And that's how you can plot a negative or positive linear equation with just your intercept and slope. Any questions? Well, that is basically it for chapter 4. Any questions of what we have learned so far? Moving on to chapter 5, which, looking at chapter 5, it looks like it's a repeat of chapter 4. Ooh. I'm gonna get into this part of chapter 5, which, of course, it touches on what we just learned, which was slope intercept. Of course, slope intercept gives me y equals mx plus b. So m, of course, is your slope. Your slope allows you to rise, then run. Your y, you rise. Your x, you run. Now, when plotting your points, you must first start with the intercept. And the intercept is always 0, comma, positive or negative b. So either it's going to be 0, comma b or 0, comma negative b. All depends on if your slope, if your intercept is plus b, or if your slope intercept is minus b. Minus b, minus is a negative intercept, plus b, positive intercept. Got me? Now, this is how you write a linear equation in slope intercept form. Now, what does it look like to write the intercept, your linear equation, in point slope form? Point slope simply says y minus y1 equals the slope times x minus x1. Now you will plot this or make this when you have a slope and you have a coordinate point, such as if my slope, which is m, equals 1/2, and my point is 2, 3. How do I write my linear equation in point slope form? Well, point slope form tells me that this is my x, this is my y, 2 is my x, 2 is my y, 3 is my y. So y minus my y1 y1, x1, y1. x1 would be 2, y1 would be 3. So my y1 is minus 3. My slope is 1/2. And my x1 is 2. So now, to write your equation in point slope form, you simply say, you plug in your y from your coordinate as your y1. The m would always be your slope, and your x coordinate as your x1. And once you are done, this is your result, especially if the equation is calling for you to only write your question in point slope form. Now, what if my 2 is negative and my 3 is negative? Well, if my 2 is negative, then my 2 is negative and my y is negative. My x and y, they're both negative. Well, y minus a negative 3 will be my y1 times 1/2 x minus a negative 2 will be my x1. So then, of course, negative to negative makes positive, equals 1/2 x, and negative to negative still makes it positive, plus 2. So just in case one of your points is negative, you must put parentheses around your negative number and change them to positive when putting it in point slope form. Any question? All right, beautiful people, I am going to stop at 5.3. We'll pick up back at 5.4 because 5.3 is the point slope. And we'll review a little bit on point slope tomorrow. Well, Friday, because we're off tomorrow. So Friday at 5 p.m., we will start back and we will touch on chapter 5, chapter 6, chapter 7, and all the key components in algebra that will allow us to learn better, grow better, and do better. So, are there any questions of what we learned as of today? Well, you guys, if you don't have any questions, I'm going to go ahead and end our live. If you have any questions outside of the live and you need any help with what we learned today, or you want additional information on what we learned today, you can IM me, you can DM me, and you can text me at 205-542-5062, 205-542-5062. Other than that, I hope you had a wonderful Wednesday. Glad you were able to get over the hump with me, Miss Chris. I am so grateful and thankful that you tuned in to all of our tutoring sessions and continue on from there. Always, I am here to help. Ask any question because all questions are important and they are very significant to me. There's no such thing as a stupid question. It's always a question that's someone else has to answer, but it's too to answer or ask. So whenever you need me, know that I am here. The video will be available on both my pages of Facebook and YouTube, so you can click on the link and allow you rewind and rewind and review what we learned for today. Other than that, I hope you have a fantastic Wednesday. Blessings unto you and your family. And until we meet again, my name is Miss Chris. This is Mathematics for You Tutorial Services, LLC, where we are changing mindsets, one problem at a time. Good night.